What's going on, everybody? We're at our next trend. Now we're talking about electron affinity. Electron affinity is the measure of the energy change when an atom accepts an electron. So the last one was ionization energy. That was how much to form a cation. This is to form an anion. However, it's the same actual trend. It's still going to increase left to right and still increase bottom to top, except noble gases are actually the exception this time. Ionization energy, noble gases were the highest, but in electron affinity, they're actually all tied for the lowest. Remember, they don't want to gain or lose electrons, so they're going to need to take a lot of energy for you to cram on another electron for there. So why is it left to right? Well, nonmetals, again, things on this side of the table, are happy to get an electron, so they are going to release energy whenever they're going to be happy. But metals, the things on the right side of the table here, they're going to require energy to get the electron to stay put, to actually be on there. And for electron affinity, all we are counting on, all we're looking for is the energy on the other side of the reaction. So nonmetals will release a whole bunch of energy, so you'll get a positive amount of energy out of it. Metals, though, you're going to have to put in energy, so you're actually going to lose energy. So their numbers will be so low because they're in the negatives for it. You actually have to put in energy to get stuff out of it. Nonmetals, when you add electrons, are relatively stable. That's what they want to do anyway. But metals will be relatively unstable. If you've ever tried to shove too many pots and pans into a cabinet and then put the door shut and kind of just hope that it stays put, that's kind of what you're doing with metals. Things like sodium want to lose an electron. So if you hand them another electron, they're kind of going to be like, what is this garbage? I don't want this. They're going to try to get rid of it. And you're going to have to force it to hold on to it. And as soon as you stop forcing it to hold on to it, it's going to release that electron and it's going to get rid of it. Increasing from bottom to top, kind of the same idea. The elements further down the table just have more electrons, so they don't notice as much, just like with ionization energy. Adding another electron to it is kind of like, if you've ever been in a situation where you've gotten something for the first time, or you've won an award for the first time, it feels really, really good. But then when it's happened the 50th time, you don't really get as excited about it. Same thing here. The elements kind of up here at the table, they're like, sweet, got my 9th electron. I'm going to get number 10. We're going to be exactly like neon. But the ones down here are like, oh, great, I have electron number 118 coming right up. Not really that big of a deal. So it just means more to the elements at the top, and they want them so badly, they want to have those electrons so badly that they're going to have a higher energy release whenever they do it. So we're just following the trend, pointing to fluorine for electron affinity, ignoring the noble gases. Sodium and magnesium. Magnesium is further to the right. It's closer to fluorine than sodium is, so magnesium must have a higher electron affinity. Vanadium or niobium. Vanadium is, vanadium is right here. Niobium is right underneath it. Vanadium is above it. That means it's closer to fluorine because it's further up. So vanadium must be higher electron affinity. Helium or francium. Well, francium is pretty low. It's on the opposite side of the table. But helium, as I said, the rule that we're going to go with for this class is that all the noble gases have the lowest electron affinity. Sure, francium really doesn't want to get another electron, but helium is already happy, and it will fight to keep that happiness, and it will take a lot of energy to get it to take that electron. And then Rb or I is right here. Rb is over here on the opposite side. I will definitely release more energy. It is much closer to francium than rubidium is, so iodine will have a higher electron affinity. So there we go, Mg, V, Fr, and I. That is electron affinity. If you have any questions, please let me know. Otherwise, have a great rest of your day, everybody. This is Mr. Diamond signing off.